So I'll start out with introductions for those of you who are joining us for the first time today. My name is Lainey Leota, and I'm the Fire Protection Market Manager for Lubrizol. So I'm responsible for our BlazeMaster CPVC and our UL listed FreezeMaster antifreeze business. Today I'm joined by three wonderful colleagues: John Pritchard, our National Technical Manager, Sean Pierce, our Business Development Manager, and Michelle Knight, who I like to call our compatibility guru. So thank you so much to you three for being here today. Today's session will be structured a bit differently from our past sessions in the series. We're going to start out by having Michelle present and share all the infinite knowledge she has about compatibility and about BlazeMaster and our FBC System Compatible program. Then we'll go over specifically our exclusive FBC System Compatible program, and then we'll have a pretty lengthy open discussion and Q&A. So again, please submit any questions you have into the Q&A section on the bottom right-hand side of your screen. So with that, Michelle, I'll start sharing your slides and you are good to go.
Hi, well, good afternoon, everyone. I'm pleased to be talking to you about compatibility of CPVC. And the first thing we really need to talk about when we talk about compatibility is what does it mean to be compatible versus incompatible? Because a lot of people have the wrong perception about compatibility. They think of it as something that's like either alive or dead. You're either alive or you're dead. You're nothing in between, right? But compatibility is really more like the thermometer or the temperature scale you see on the right-hand side of the screen there. Chemicals vary in the amount of effect that they have. Some of them have a lot of effect, some of them have a little bit of effect. And just like a thermometer, there's a lot of degrees of warm and cool in between very hot and very cold. And so when we talk about measuring compatibility or determining whether something is compatible or incompatible, the question we're really asking is how hot is too hot? And one thing that we have to keep in mind also when we're talking about compatibility is the fact that other factors may contribute to compatibility failures, and those things need to be taken into consideration as well. We'll be talking about that in a little bit later of a slide. Now, compatibility is not necessarily a concern of just CPVC or just plastics in general. So, like I was saying, not many materials are impervious to everything around them. Gold and diamonds kind of come to mind, like the picture you see on the right there. But not very many other things are really impervious to everything around them. And anything that you can find that has that degree of resilience to chemical effects is probably going to be just as expensive as gold or diamonds. So, you know, we're all familiar with the fact that metals can be sensitive to oxygen in the atmosphere, salt, especially if you live near the ocean, water, humidity in the air, or water from leaks in the building, something like that. The quality of the water, if the pH is too high or too low, microbes growing inside that stagnant system. Everybody's seen the effects of galvanic corrosion here and there, and stray electric current can also affect metals. Some of you may have switched to CPVC in order to combat some of these effects that can cause metals to fail. So some other plastics can also be sensitive to some of those things: oxygen in the atmosphere, the quality of the water that you put into the pipe, and UV exposure from sunlight or from some types of lighting in buildings can also affect certain types of plastics. CPVC is really, really resistant to those types of environmental effects. So if you'll move to the next slide, Lainey. Those types of things that are out of your control, like whether there's humidity or salt in the air, whether the pH of the water is too high or too low, whether there's UV present around the building, those things that are kind of hard to control, CPVC is actually highly resistant to. So this blobby red and gray and blue picture that you see in the middle is actually a 2-scale representation of a small segment of the CPVC molecule. And I like to call CPVC kind of an armadillo of a molecule. In order to break it down, you have to break those gray blobs in the middle apart from each other. And you can see all the big red chlorine atoms stuck to the outside of the molecule are basically like armor on that molecule. And they are protecting the backbone, which is the string of gray atoms in the middle. they're protecting that backbone of the molecule, and it is really hard to break it down. So CPVC is really resistant to things that can degrade a lot of plastics and a lot of metal. And in fact, we make CPVC in an environment of intense UV light and chlorine gas, and we're not degrading it when we're doing that. And this is the fire sprinkler industry. You may not know that CPVC is also used in industrial applications. We make industrial pipe out of it as well. It's used for handling really strong acids, really strong caustics, peroxides, very corrosive chemicals. And in industrial applications, it's frequently installed outdoors for decades without any problems. So it's really resistant to those kinds of things. However, CPVC can be caused to fail by a process called environmental stress cracking. And that can be triggered by chemicals, in a few types of chemicals that can be found in construction type environments. But in order to understand how that occurs, we need to understand what's holding that plastic together as a solid. And so we're just going to touch on this really quickly. And we're going to start on the right side of the screen. Some plastics, like that fiberglass ladder you crawl up every day, those are held together with cross links. The molecules are actually tied together chemically. And those bonds can't really be melted or dissolved. That's a very strong way to hold plastics together. That's not CPVC. In the middle, some types of plastics, like polyethylene sheeting, you're probably familiar with, that's held together by crystallization. So the molecules pack together in tight little bundles, which is what's represented by all those parallel lines you see in the middle of that squiggly picture there in the middle of the screen. So those tight little bundles can be easily melted by heat, but they can't be easily dissolved by chemicals. And so these types of plastics aren't very sensitive to environmental stress cracking. But CPVC is an amorphous plastic, which is what's represented on the left there. It's held together just by molecular entanglement. All the long chain molecules of CPVC are just tangled together, and that's what holds it together as a solid. So this type of a plastic can be softened, but surprisingly not melted. CPVC does not even have a melting point. It doesn't melt. But this type of plastic can be fairly easily dissolved. Now that's a good thing when you're talking about solvent cementing. It makes solvent cementing possible. The fact that you can dissolve the surface of the pipe and dissolve the surface of the fitting and force that pipe and fitting together and make a chemical weld. However, it also means that other types of chemicals can affect the plastic as well. So if you'll move to the next slide, please. Now, if you remember back at the beginning, I said that other things can affect the besides the chemical can affect the plastic as well. Other things are contributing to the failure. And to illustrate this point, I like to use the fire triangle because we're all familiar with that in the fire sprinkler industry. You need 3 factors to make a fire happen. You need fuel, heat, and air. And if you remove any one of those factors, you don't get a fire. And in fact, that's the whole point of extinguishing fires, is either to remove the air or the heat or both to make the fire go out. So it's very similar with environmental stress cracking of plastics. It's not just the chemical. There are mechanical stresses that can contribute to the failure, and the material and part properties as well. And we're going to touch on material and part properties really quickly and touch on mechanical stresses quickly, and then we're going to talk about the chemicals themselves and where you might find them. So on the next slide, we're going to talk about material and part properties. Here's our little armadillo of a molecule again. This is the CPVC itself. That's, of course, you know, a really blown up representation of a single molecule. When you look at it in person, it's a white powder. We add other ingredients to that white powder and pigments to make it orange, and that makes the BlazeMaster material, which is what Lubrizol sells, and it comes in powder or pellet form. We sell that to manufacturers like Tyco or Viking, who turn that into pipe and fittings. And so if you think back to my picture of molecular entanglement, you've got all these individual grains of powder that you have to make into a solid piece of pipe for a fitting. And so you need to get all of those molecules that are in those individual grains mixed up and entangled very well. And that's not necessarily easy to do. And so the whole point of this slide is that it's very important to choose a supplier that has a high reputation for quality manufacturing. And that's what you get with BlazeMaster and the manufacturers who make BlazeMaster pipes and fittings. They've been doing this a long time. This is a difficult process. It's not easy to do, but they know what they're doing. And that's why you want to specify a high quality brand like BlazeMaster. So moving on to the next slide, we're going to talk about mechanical stresses. So the chemicals, if you think about that entanglement of molecules, it's kind of like a plate of spaghetti, really. If you have no olive oil on your spaghetti, it's hard to pull the strands apart. You put a little olive oil on, and that chemical acts as a lubricant to help you pull those spaghetti strands out. Similarly with the molecules, some chemicals can act as a lubricant to disentangle those molecules. But you still have to stick your fork into the spaghetti. You still have to apply some kind of stress to pull those molecules out. And so sources of stress in a piping system, some of them are really obvious. There's pressure inside the piping. It's got to support its own weight. You're aware probably that there's an interference fit in the fittings, so that the bottom of the fitting, the bottom of the socket is a little bit smaller than the outside diameter of the pipe. That makes a nice tight joint and a good solvent weld when you're solvent cementing, but it does put stress on the fittings. But some of the stresses are represented in this picture on the right, and at first glance it doesn't look too surprising. You've all probably seen something like this before, but there's an awful lot of cabling conduit there, and it's resting on the pipe. So the pipe is supporting the weight of all that wire conduit to the point that it's actually bending it down. If you look at it, you can see that the pipe is curved down somewhat. So it's the weight of all that conduit on the piping is a stress. The bending is putting a lot of stress on the pipe at the entrance to the T-socket there. And it's actually pushed the pipe so far down that now it's pressing down on that metal ceiling grid there. And so you've got impingements on the bottom of the pipe as well. So there's a lot of different stresses represented in this particular picture. Now, CPVC can probably handle these stresses pretty well in a normal situation, but if somebody comes through and sprays some sort of incompatible mold inhibitor, disinfecting type chemical or something around this building, then those sources of stress can be a point where the pipe may fail. So moving on to the next slide. A lot of people are kind of confused and maybe overwhelmed a little by chemical compatibility. It seems like there's a lot of things that could be incompatible, but it really boils down to three different types of chemicals, really just three different types. One is plasticizers, which is a chemical that's used to make rubbery things soft and rubbery, or to keep them rubbery throughout their lifetime. The other type is natural or synthetic lubricating oils. And at this point, I like to make the point that it's not petroleum. Everybody's probably heard in the industry that petroleum oils can harm plastics, but good old mineral oil is actually pretty highly compatible with CPVC. When I'm talking about oils that are incompatible, I'm talking about natural type of oils. So things that would be advertised as green or environmentally friendly or vegetable based, those types of oils can be incompatible with CPVC and their synthetic equivalents as well. And then the third type of chemical is surfactants, which is a chemist's term to describe soaps or synthetic detergents. Now, not every kind of soap is incompatible with CPVC, but there's one particular class of synthetic detergents that can be an environmental stress cracking agent for a lot of different plastics, including CPVC. So on the next few slides, I'm just going to give some examples of where you can find these types of chemicals, things you need to look out for, and maybe ask a question if you see this kind of product in contact with the CPVC piping. So on the top right, you see communications type cable, and it is particularly communications type cable that is of concern. The ordinary Romex type wire that carries just electricity around the building to outlets and fixtures and so forth, that has a different type of jacketing on the outside. But communications type cable, that soft rubbery jacketing on the outside of that type of cable, can contain plasticizers to keep that rubber soft, and anything that makes that jacketing soft can also make CPVC soft or weak. And so then on the bottom left there, you see caulks and fire stops. There's another rubbery type of material that can often come in contact with CPVC, and they can sometimes use plasticizers to keep those caulks and fire stops soft and rubbery throughout their lifetime. So some of those may be incompatible as well. On the top right, you see some black tubing insulation, and I've particularly made the point that squishy tubing insulation is the one that we are concerned about. If you've been to Home Depot, you're probably aware there's two different kinds of tubing insulation you can buy. One feels kind of crisp, like a pool noodle toy. That one is typically compatible with CPVC, and you shouldn't worry about that one. But there's another kind that feels soft and squishy and more rubbery than the pool noodle kind. Those can contain plasticizers, and so it's the crisp pool noodle type that you want to use, the squishy kind you want to avoid. And then the last picture I have on the screen here is electrical tape, and I'm talking in particular about electrical tape. Any other kind of tape, duct tape, painter's tape, masking tape, scotch tape, strapping tape, those are all compatible with CPVC. Those are not a problem. But that soft, rubbery, vinyl electrical tape often contains plasticizers to make that plastic material it's made out of soft and rubbery. And so that particular type of tape should be avoided. So on the next slide, we'll talk about vegetable oils or synthetic lubricants and where they can be found. One of the most common places is incompatible thread sealants. You can find a lot of compatible ones on the System Compatible program, which Lainey's going to talk about in a few minutes. But some types that aren't listed as compatible with CPVC may contain vegetable type oils, which are incompatible. I mentioned cutting oils was one of the things I mentioned when we were talking about oils in the first place. So particularly, again, what I'm talking about here is green or environmentally friendly or vegetable-derived cutting oils. The good old mineral oil-based cutting fluids are typically compatible with CPVC. And then one thing that actually comes up occasionally is kitchen grease. If you've ever cleaned your kitchen at all, you know that when you cook, the grease can rise and then settle down on things in the kitchen, and it has to be cleaned off. If the piping is behind the ceiling, like it is in the picture you see here, that's not going to be a problem for the CPVC. It doesn't typically get past the ceiling, but in a few cases I've seen where it's been exposed in a place where kitchen grease can settle down on it, and kitchen grease is of course vegetable oil or animal fat, and that can harm the CPVC. Anyway, like I said, kitchen grease, if it's behind the ceiling or behind something that's going to protect it from the grease settling on it, that won't be a problem. But if it's exposed, then it really should be protected from having the grease settle on it. The next slide, please. And synthetic detergents. I couldn't come up with any pictures for these except a picture of a piece of pipe that actually failed due to synthetic detergents, because they're liquidy things. They don't look any different. But they can be found in things that you would expect to find soaps and detergents in. So leak detectors, cleaning products, disinfectants, mold and mildew treatment. And that actually, this picture actually demonstrates the stress that is in the fitting sockets. So I said, you know, because of the interference fit, there's stress on the fitting sockets. So when you put these types of things on the outside of the fitting, the highest stress point typically is the fitting sockets, and that's what will fail with synthetic detergents. So moving on to the next slide, this is something that's kind of a special case, and it's a frequently asked question. So I did want to talk about it here. Spray polyurethane foam, is CPVC compatible with that? And the answer is yes and no at the same time. So as you're aware, CPVC is not CPVC, polyurethane foam is a two-part product. You mix part A with part B, and it reacts and foams up to make the insulation. And what you want to see is what you see on the left-hand side there. It's all well foamed, there's no discoloration, everything is well reacted, and it looks very uniform. CPVC is actually not compatible with either part A or part B. So if it doesn't react well, if you have an excess of part A, part on the plastic, like you see in the bottom left, in the center on the bottom there, then you can get cracking of the plastic. It doesn't foam up very well, like you see on the top right. It's actually the foam structure that allows polyurethane foam to end up as compatible with CPVC if it's done right. So like I said, it's not compatible with part A or part B, but when they react together, then once they've reacted together, the A and the B are effectively gone, and they've turned into that rigid. And the additives that were in part A and part B are now lifted up off the surface of the CPVC by the foaming, and there's all these bubbles present in between the additives that are lifted up and the surface of the CPVC. And effectively, the additives can't transport themselves around all those air bubbles, and so they never get back to the CPVC surface. So it's only the fact that it's properly installed and foams up properly that allows polyurethane foam to be compatible with CPVC. If it's not done well, if it doesn't react or doesn't foam properly, then there can be issues with compatibility. And then the final thing I want to talk about is the picture on the bottom right here. That's actually a piece of CPVC pipe that was buried in polyurethane foam. And when polyurethane foam reacts, it actually gets very, very hot inside that foam as everything's reacting and foaming. It can get well over 300 degrees. And that's what happened to that pipe on the bottom right. It was buried in the foam. It got well over 300 degrees as the chemicals were reacting together and producing heat. And it literally boiled the water inside the pipe and caused the pipe to balloon up and get thin and eventually burst and rupture. So when you are going to be burying CPVC and polyurethane foam like that, it is best to do it while there is no water in the pipe that can boil. Moving on to the next slide. I wanted to throw in a slide about things you don't need to usually worry about. And I've mentioned a few of these as we've gone along, but some of the others are kind of frequently asked questions. So on the top left, you see paint. We get this question an awful lot. Almost every kind of paint is not a problem for CPVC, but again, it's like polyurethane foam. It's not in every circumstance. You don't want big puddles of paint that can't dry quickly around the CPVC. And certain types of paint, like two-part epoxies, again, CPVC wouldn't be compatible with part A or part B, but once it's cured, it's fine. So as long as the paint gets applied in a normal way and it dries or cures in a normal amount of time, you're not going to see an issue with compatibility. But in those weird cases where you might have, you know, a big puddle of pipe spilled around the paint or something like that, then you might need to have some concerns about whether that's going to harm the CPVC. I mentioned when we talked about electrical tape, you do need to worry about electrical tape, but any other kind of tape, like the duct tape you see here, or masking tape, scotch tape, strapping tape, any other kind of tape, those are compatible, no problem with those. Sharpie markers if you feel like you want to write on your pipe in order to give directions or label it or something. Sharpie markers are just fine. You don't need to worry about those. This kind of flexible ducting like you see in the top right here, those are all fine, compatible with CPVC, no problem with those. Bottom left, you see fiberglass insulation, blown in insulation, whether it's cellulose type or fiberglass type, all of that is perfectly compatible with CPVC. Drywall mud, spackling, those types of things are not a problem. And on the bottom right there, you see that spray applied cementitious fireproofing type materials. Those are also compatible with CPVC and nothing to worry about as it comes to compatibility. So those are some of the most commonly asked questions which have answers that are, don't need to worry about that. Lainey's going to talk now about the System Compatible program. So I will let her do that.
Great. Thanks so much, Michelle. As always, that was an excellent presentation of compatibility, and it's always great how you can simplify it into things that people can understand, or at least I can understand, not being a chemist. So I really appreciate that. So to kind of put a bow on it around compatibility, Lubrizol has a program called the FBC System Compatible Program. And what FBC stands for is FlowGuard, BlazeMaster, and Corzan. And those are 3 brands of CPVC that Lubrizol manufactures, or we manufacture the compound for those 3 brands of CPVC. And what the System Compatible program does is it just eliminates the guesswork out of compatibility on a job site when it comes to BlazeMaster. We invented CPVC and we invented CPVC compatibility the CPVC compatibility program. It's the oldest and most comprehensive, most robust program in the industry. We do not do the testing ourselves, and contrary to popular opinion, we do not profit from it. It is tested by a third-party lab for compatibility and sort of either approved or not approved for our list by that lab. And then we actually, or the lab actually tests the manufacturer's products that are on our list annually in order to make sure that the formulation hasn't changed or that no incompatible product has been introduced into the formulation, etc. So it's an annual process that's checked just to make sure that we're being as safe and as reliable as possible. Another thing that is kind of a common misconception is that the FBC program applies to all brands of CPVC, and that is not true. Our FBC program for the fire sprinkler industry only applies to BlazeMaster pipes. So that's Tyco, Viking, and Ipex in Canada, and George Fisher, Harvell in some areas like Vesda Systems. It does not apply to Spear CPVC pipe. There are differences in the molecular and chemical makeup of CPVC where there could be compatibility differences. So, you know, that's just very important to understand. If you have a question about a different competitors or a competitive CPVC's compatibility, you need to go to either the manufacturer of the product or that the manufacturer of the CPVC. And then we have a ton of support resources to offer you in order to make your job easier. Two really helpful tools we have is our FBC System Compatible website, and we have an app, and it's called, I think it's just the FBC System Compatible app. It should be available in most places globally. But what I wanted to do is just take the opportunity to go through how to use the website real quick. Because it isn't, I'm not going to lie in that it's the most user-friendly, but I think there's one very important part of the site that I think a lot of people miss. So if you go to just fbcsystemcompatible.com, or you can go to blazemaster.com and click on a compatibility link, you'll be taken to this page. Now, to find a compatible product, what you do is you go over here to the right and click Find FBC System Compatible Products. Here you can select the category of what type of product that you're looking for. So we'll just do fire stock collars, for example. You can select your region, and then there's a list of compatible products. Now let's say, obviously, not every single compatible product can be part of our program. So if what you're looking for is not on our compatibility list, we do recommend using a product that is on our compatibility list, because it just takes the guesswork out. It's a lot easier just to move forward with the product that is already approved. But in the case that it's not, you're not done yet. The second step should be going up and finding incompatible products. So you go up to the right-hand side and click incompatible products. And then, as Michelle mentioned, there are different levels of incompatibility. It's not just compatible or incompatible or dead or alive, as she mentioned. So we have products listed that we know to be a certain level of incompatible with BlazeMaster. And we list those products here. So if you're looking for a fire stop collar, you should go down to that section and make sure that the product that you are looking for is not listed on that list. And you're still not done. And this is the part that I think a lot of people are unaware of, that will be really helpful to you guys in the field and when you're dealing with builders and other trades on the job site, is this section called Other Compatibility Topics. If you click on that, it takes you to a list of basically every type of category that you can find on a job site, and tells you what you should look for in the ingredients of an ancillary product on the job site that should be incompatible, that are known to be incompatible or compatible with CPVC. It's a lot of guidance. There's a ton of guidance on what it is, what isn't, things you should look at in the SDS. And I think that this is probably the most helpful part of our website, and can save you a lot of time in sending an email to the product manufacturer or to us and going back and forth, because that's probably the #1 question that we get through our inbox is this compatible? Is this compatible? Is this compatible? And really what we do is we just kind of screenshot the website and send it back to you in an email. So what you should do is you can get that information yourself by going to fbcsystemcompatible.com and going to the Other Compatibility Topics page, and you'll see there's just a ton of guidance on different categories of building products. So hopefully that is something sort of new that you learned. I just wanted to take the opportunity to point out, we have that entire website with hundreds of products listed in amongst the categories on the FBC compatible program. And like I said, it does not apply to the competitive brand of CPVC, so Spears, FlameGuard, or any of their CPVC brands. This is just a screenshot or copy and paste of text from Spears's compatibility program. They do not test annually to make sure materials are still compatible. There's very limited oversight, and it's not done by a third party. It's done by themselves. So I just want everyone to sort of be aware of the differences, because I think, as we all know, there have been failures. There was even a case where something was listed on our FBC compatible program as an incompatible product. It was a firecaulk, and it was listed at the time on Spears's compatible program. And there were several failures, mostly in the Southwest and Southeast US. And we knew that product was incompatible all along and did not recommend its use. So there can be differences, and it's just really important to realize, that each manufacturer has their own compatibility program, and they are different levels of robustness. So with that, I think it's time to move into the Q&A section. I see a lot of good questions in the chat. So I think we will start out with, John and Sean and Michelle, if you could join us again, that would be great. One thing I definitely wanted to talk about before we get to some of the questions is if there's a product that's not on the list on our FBC system compatible program, and there's not necessarily you can't find the guidance that you need on the Other Chemical Compatibility Topics webpage, what do you do? And John, I think you're probably a great person to answer that.
Thanks, Lainey. Well, NFPA 13R13 a couple of years back did a good thing, and they actually are requiring you to prove compatibility for all ancillary products when you're doing a CPVC system, which really is front end stuff and it really avoids a lot of the problems. But unfortunately, you have a lot of ancillary issues that may come up. First, we would like you to possibly contact directly the manufacturer of that product. And I'll tell you why, because a lot of times we will get people ask us to look at a certain product, and it's really hard to make a good determination because there's a lot of things that happen. One, sometimes we don't get all the information. Sometimes it might be dated. And typically what we see with SDS sheets is you don't have all the ingredients. And a lot of those typically are proprietary to that specific material. This week earlier, I got a contractor that asked us to take a look at a mold inhibitor. This contractor was making sure it was going to be good to put on our pipe. Michelle looked at it, and it was actually a very good SDS, but it only had about 95% of the makeup of that mold inhibitor. And since it wasn't applied to the pipe, I recommended and sent the section from our FBC system compatible guide where under cleaners, disinfectants, and mold inhibitors, we actually have 9 products. And since it wasn't applied, we recommend to that contractor, it would be a lot better to use a product that's gone through our whole testing process. And with that testing process, it's going to be a long-term testing where the product is going to be applied to the CPVC with the pipe under stress to really recreate a real-life installation of that to make sure it's going to withstand the test of time with CPVC.
Thank you very much, John. I think that's a great answer, and kind of, I know some people get frustrated when they ask us, is this product compatible or not? And we really can't say yes or no unless it goes through the testing, because as we all know, a lot of products are proprietary, and so we do not know every single chemical that or material that goes into the product. So that's what makes things difficult.
Like that one thing, when Michelle looks at those and reviews them, she can usually flag red flag items that are going to be a concern right off the bat. But we're never going to be able to give finite, guidance on just reviewing an SDS without doing complete testing.
Definitely. And so we do recommend that you go to the product manufacturer first. One question that I saw in the chat that Dave Nungare asked was, whose job is it to find out if something is incompatible with CPVC? And I want to answer that. He asked, is it the manufacturer or Lubrisol's? But I also want to ask that question from a job site standpoint. Is it the contractor? Is it the builder? Is it the developer, the GC? First of all, who's responsible for that? And then second of all, I think we already addressed that you should go to the manufacturer first, and then we can always jump in as needed if it's something not on the FBC program. But in regards to the job site itself, who is responsible for compatibility?
Typically at a job site, the first person is going to be the contractor to really look out after his own work. And it's important that he has that conversation. This is all pre-planning of the job site to really educate the general contractor and some of the contractors he may be working with. Your painter who may be applying, an antimicrobial coating, or your insulator who may be using spray foam may not be familiar with the process of using their product with our pipe. So if we do a lot of front end work to make sure everybody's on the same page and everybody safeguards keeping an eye out through the course of the project is really the best recommendation we can give.
Thanks, John. So I think we'll kind of move into, before we move into the Q&A section, what I wanted to go over with you guys is best practices in the field. I think you guys deal with various stakeholders across the construction industry and are in the field every day. What are some best practices that you've seen people do in order to ensure that everyone on the job site is taking compatibility with BlazeMaster and other CPVC products seriously?
you know, there's a number of resources that our partners at Tyco and Viking and IPEX have available. Our job site notifications are available. They should go in with bid documents. I know John talked a little bit earlier just now about who's responsible. I think everybody on a job site's responsible for compatibility. And the one thing I try and make clear to everyone, and I think it's really important, is that our program isn't a reactionary program. It's to get people out in front of compatibility. So everything on a construction site has compatibility issues. What we do with our program isn't to respond to compatibility. It's to allow everybody to be out in front of it. And I think that that's a critical part of this program that a lot of people don't really understand. Something happens, something touches a pipe, they respond, and the tool, the FBC app, makes it easy for them to respond. But really, with the job site notices and making sure everybody's aware that as a contractor that compatibility affects construction products. You're using a product that has a program. The site super should have a job site notification in the construction trailer. One should have gone in with your bid documents. Hang them, at the buck hoist elevator or at the washroom on a job site. That's where people congregate, and they're most likely going to read them. Get out in front of compatibility, because that's the easiest way to manage it. Absolutely, there's John, myself, there's all the TMs across North America that'll support anybody from a reactionary standpoint, but the best way to handle compatibility is to be out in front of it.
Thanks, Sean. And if anyone is looking for where to find these job site notices or the turnover letter to print out, what you can do is you can go to the pipe and fitting manufacturers' websites. But what we recommend for BlazeMaster is just going to blazemaster.com. You click on the Buy tab, and then you select whose pipe and fittings that you're using, whether it's Tyco, JCI, Viking, or IPEX. And then the links to all of the installation resources, including the installation guide, the turnover letter, the job site notices, and even more are right there on the website. And so that's kind of just an easy way to remember where to find it instead of having to dig through everyone's website. So I think last question before we get to the Q&A is there, a lot of people ask us about using compatibility barriers. So do people use those in the field? And if so, how and what have you seen?
So there's a number of things. Of course, our pipe is specially listed, so you have to maintain our listing as well. Typically, what people will do is take a bat of fiberglass insulation and separate something that they might consider to be incompatible with the pipe. There are other things you can do to separate it as well, but AHJs are often looking to identify something that may not only be compatible, but may be a contradiction to the listing. Fiberglass is probably one of the safest things you can use. Ultimately, the other trades should be doing their job properly and properly suspending their wiring and everything so that it doesn't come in contact with any sprinkler piping. NFPA is pretty clear that sprinkler piping isn't meant to support anything other than its own weight, regardless of whether it's steel or CPVC.
Thanks, Sean. All right, Michelle, I just want to check. Are you still there?
Yes, I'm still here. Yes.
Okay, just wanted to make sure. So let's move on to getting some of these questions, and I think it'll be interesting to hear from Michelle from sort of a technical perspective, and then John and Sean, if you have experienced anything relevant in the field or with engineers, I think it would be great if you guys could comment on that as well. So one question that just came in was, and Michelle, I find this interesting, and I have my own opinion on this, but I'm interested to hear your thoughts, is you had mentioned that CPVC can be used in the sun or can be exposed to UV light. How and where did the rumor come from about that it can't be put in the sun?
Well, there are a lot of plastics, and particularly like PEX piping that's used for plumbing that really can't be put in the sun. The UV light will degrade them and deplete the antioxidants that keep them from degrading. So it might be that CPVC is conflated with other plastics, or it might also be the fact that if you do leave the orange pipe out in the sun, it does tend to fade. But the fading doesn't really represent any kind of degradation of the material's properties. It will still hold pressure. It will still function as a fire sprinkler pipe just fine. It may get a little bit more brittle laying out in the sun. It may make it a little more hard to cut with a ratchet cutter. You may need to be a little more careful cutting it. But if you can get it cut and installed without cracking it, it will continue to hold pressure for the life of the building.
Thanks, Michelle. And I think even in some of our documentation in the past has been very kind of cautious of saying that BlazeMaster can be exposed to UV light, and I'm not really sure where that came from, to be honest. And I think it just caused a lot of misconceptions. But as Michelle said, we have even done testing on pipe that has been exposed to UV light, and as she said, there's no material degradation, anything like that. It's just if it's out in the sun prior to install, it can make that process a bit more difficult. So special care needs to be taken. So another question that came in was, Michelle, what do you advise when working on an existing system where thread sealant and cutting oil may have been used, and there's no documentation of what kind of thread sealant and cutting oil was used?
Well, it really depends on how old the system is. If the system's more than a couple of years old, whatever kind of thread sealant or cutting oil that was used and maybe in the system or on the adapters or whatever is probably not going to hurt the pipe. Usually the failures that we see from environmental stress cracking happen in the first couple of years of the life of the system. So if it's more than 2 or 3 years old, whatever's on there is probably good unless you are seeing failures. If it's less than a couple of years old, I would say you really need to try to find out who did the work and see if you can determine what is on the pipe. If not, it may need to be monitored. If you do start to see problems, you may need to be concerned that it might be prevalent in other places. So hasn't been mentioned, but there are failure analysis services offered as well. So if there is any question that, you've had a failure, say where a fire caulk has been used and you don't know if the fire caulk is incompatible, there are failure analysis services available through the manufacturers like Tyco and Viking in order to determine whether that caulk was contributing to the failure.
Sean, have you? I'm sure you've dealt with this in the field. Have you ever experienced where you start seeing a system failing or anything like that because of a cutting oil or incompatible cutting oil or something?
I've seen instances where the pipe dope has been the root of a cause of problems. When we ended up testing it, it did determine that wasn't incompatible caulk or thread sealant that was on our do not use list. Unfortunately, the installer wasn't versed and didn't know about system compatibility and just elected to use something that he had on his truck.
So one question that is a great question that I definitely want to make sure we get to is, if a product was previously identified as compatible and it is now on our list as incompatible, what action should be taken on an existing system where that product is used? Michelle, has there ever been a case where that has happened?
We've had the system compatible program out there for about 20 years now, and I can't think of any case where something has ever been listed as compatible and then became listed as incompatible. We have had manufacturers leave the program for whatever reason. Either they don't care to pay for the annual costs of having their product tested, or they don't feel like it's offering them any value. And so if they leave the program, then obviously they're going to leave the compatibility list, but that doesn't mean that they've become incompatible. It just means they're not participating anymore.
And I would say that happens, anytime we have a list on the FBC system compatible website with changes that have been made in the past quarter to our compatibility list. And if something is removed from our compatible list, that does not mean that it's incompatible. It just means, like Michelle said, that the manufacturer of that product chose to no longer submit their product for annual testing and chose to opt it out of our program. So if something, in the event that something was on the compatible list and then all of a sudden, something changes in the formulation and it's now on the incompatible list, that has never happened. But if it does happen, there will be a lot more communication between the manufacturer and us and you guys to make sure that we're handling that accordingly. But I don't foresee that really ever happening, nor has it happened. But I think that's a great question. Let's see. What about drips or streaks of joining cements? Will that affect CPVC and degradation of CPVC at all?
Could you repeat the question? I didn't hear it.
Yeah, drips or streaks of joining cements.
You know what, Lainey, this is a question we get all the time, whether it be from AHJs, installing contractors, or engineers. The concept of how much cement is too much cement. And Michelle, I've been back and forth with Michelle on this a number of times, and she really explained it to me the best, that there is a component within the cement that is incompatible with our pipe, and that is there for a reason. It's there to soften the surface of the pipe and the fitting so that they can chemically weld. And as the cement cures, that incompatible component gases off, and the cement is fully compatible, and it welds itself together as a single unit. If it's never good to have excess cement, because you could disrupt the waterway inside the pipe. But if that cement has had adequate time to cure, where that softening agent has fully off-gassed out of the cement, then you won't have an issue with it. But if you don't use the cure time charts, or don't allow that cement to cure, and you button the system up either with sprinkler heads or putting water in the pipe, then that cement won't cure and could effectively continue to soften the pipe and cause a failure. And I know Michelle's on the line, so Michelle, tell me if I said that wrong, but that's the messaging that's out there now.
No, I agree with what you said, Sean. And the other thing I would just say is it's very hard to have too much cement on the outside of the pipe, because it can evaporate. That solvent that softens the pipe can evaporate very easily. What you do not want is anything puddling on the inside of the pipe where it can't evaporate very easily.
Thanks, Michelle. Thanks, Sean. Another question we have is, NMD 90 wiring for basic building electrical is marked as nylon and is often coated in a PVC jacket. We found that the nylon is referring to the coating on the internal wires. Is the PVC jacketing compatible?
Well, I'm not familiar with that particular kind of wire. Usually the electrical wire has the nylon on the outside and the PVC on the inside. It's the PVC jacketing that is incompatible. So if you have a wire that has PVC jacketing on the outside, it's probably incompatible. But like I said, usually electrical wire has the nylon on the outside.
Thanks, Michelle. How quickly could a failure occur from a product like the soft foam pipe insulation?
Well, Well, soft foam pipe insulation is kind of a special case because it's not a real close contact. So if you remember the picture I showed, it had a metal pipe with that insulation over it pressing up against the CPVC, and that caused a failure within, I think, 5 years. The plasticizers can take longer to migrate out of incompatible materials, and especially a foamy one like that, because again, you have air bubbles kind of in the way. So that one could be longer, but most incompatibility failures from surfactants or oils tend to occur within the first 2 years.
Great, thank you. So if a pipe has been exposed to an incompatible sealant or an incompatible product, can someone observe a difference in the exterior of the pipe, such as discoloration or a streak? Like, what are some indications of incompatibility?
If you can peel up a caulk and feel that the pipe is softened underneath it, that's a bad sign. Some types of caulks will cause discoloration, but some types of compatible caulks will cause discoloration as well. So that's not necessarily a sign. But if you peel up the caulk and you can kind of put your thumbnail into the pipe underneath it, that's a bad sign. It's starting to make the pipe soft.
Great. So I think 2 more questions. Is there a time after which ESC failures are no longer likely to occur if an incompatible product has been used?
Well, like I said, plasticizers can take longer. Those can take up to 5 years. I've even seen one go as long as 9 years. But with things like oils or surfactant detergent type chemicals, those are usually within the first couple of years. However, we often see issues where the system is 15 years old and somebody comes along and sprays something on it. So it's not necessarily the age of the system, but it's when the chemical came in contact with it.
Thanks, Michelle. And last question, I don't know if this would be for John and Sean or you, Michelle. For retrofitting an old steel system, are there any specific recommendations, such as, draining the product or anything like that? What sort of precautions should be used?
Yeah, Lenny, if they're talking about like a full retrofit in pulling pipe out of a suite, I mean, there is always the chance that there may be some residual cutting oil in a system. If the system has had its annual inspections done and flows to the most remote part over I don't know how many years, I think the likelihood starts to go down. But it is always a consideration depending on the age of the system, and you'll never know what cutting oil was used when the system was installed. So I think care has to be taken for sure. And if that means if you have to flush, then because you can't find any answers to any of your questions, and I think that should be a consideration. But yeah, that can be a difficult question to answer because no one's ever going to know what was used in the original installation.
Right. Well, that we are about a minute over, so I wanted to thank everyone again for joining us. We hope that you learned something valuable, something new. In the meantime, you can always reach us at blazemaster@lubrizol.com or by visiting www.blazemaster.com.